Hello all, welcome back to my channel. I'm Raju Pujala. In this video, let's quickly take a look at hyperparameter tuning. What exactly is a hyperparameter tuning? So for any model, once you train the model, so you are achieving some kind of accuracy, maybe like some 70 percentage or 80 percentage or 85. So what else we can do with the model? So is this is the end? No, not exactly. So there is something called hyperparameter tuning where basically you can change few of the default values within the model and to see whether you can increase the accuracy or what else you can do. Sometimes this can increase your accuracy or sometimes this can decrease your accuracy. So this is like a trial and error method. So there are two types of hyperparameter tuners. One is the randomized search CV. The other one is a grid search CV. So both of these methods, they're almost similar, but there is some variation in between these two. So let's take a look at randomized search CV first, and then we will talk about the grid search CV. So let's directly jump into the collab. Okay, so this is our collab. So this is how hard disk data set. I'm deleting all the existing cells. Let me zoom out. Okay, so I hope this is visible. I'm copying this one. So what we will do, so let's import the library. Let's upload the data into the pandas. Read CSV, low memory is equal to false. Okay, df dot head. So we already have done data exploratory analysis on this data set, so I'm not going to do anything again here. So let's split this data into x and y. X is the features, y is the label. So x is equal to, so what we are going to do first, we are going to develop a model and train the model and see the accuracy, and then later we will try to see whether we can improve the accuracy. So let's go ahead and let's start developing a model. This is something that we already have seen earlier in all the videos. So I'm just going a little bit fast here. X of 2, y of 2. Okay, and now let's split the data from sklearn model selection. Let's import train test split, and also I would like to have numpy random.c. So this is optional for you. If you, in case if you do the same number, you will get the same split like how it is happening for me. X train x test, y train y test is equal to train test split x y, test size is equal to 0.2, random state is equal to 42, stratify is equal to y. Okay, so it is very much important to check the shape once after we split the data. So this is 5 to 42 to 42, y test dot shape. Okay, so let's develop the model, the ML model. For that, let's do logistic regression for this. Random forest classifier from sklearn.ensemble import random forest classifier. So let's call RF random forest classifier. N estimators. This is one of the hyperparameters. N estimators is equal to 100. I will quickly show you the rest of the other parameters as well. Dot fit x train y train. Okay, so let it run. It ran. So rf dot score x test y test. Let's see the percentage over here. It is like 83 percentage. I mean, you can also print nicely if you can save something like this one as into 100, 83. So let's do the round of here, round of this one comma to 83 point. Okay, accuracy, let's see this like accuracy here we have achieved is this one. Now let's see all the parameters over here. Rf dot get params. Okay, so all of these parameters are other parameters. For example, you can see here n estimators is equal to 100. This is the default one, and rest of these values are also the parameters. So hyperparameters. Now what I'm going to do, for example, see here, there is something called maximum depth. This is something called none here by default. Now I'm going to change this none to some, will give some other values, and then I will, for example, I'll give some maximum depth as 1 and 2 and 3. So I wanted to check how it performs on maximum depth is none, when it is 1, when it is 2, when it is 3, and whether it is improving the accuracy or not. This is what we are going to do. So let's start doing hyperparameter tuning. Okay, so let's import the models from Scikit-Learn dot model selection again. So import randomized search CV. This one is already here. If you see over here, we already have this in my first video, randomized search CV and grid search CV. Okay, and now what I'm going to do, let's so we already have the x values and we already have the y values. Let's create a grid. Okay, let's take these values. Let's start with n estimators, this one, n estimators. So by default it is like 10, 100. Now I will give like 10, 50, 100, 150. Let's see. Okay, you can pass as many as you can. Okay, now let's do the maximum depth. So here the maximum depth right now it is none. So I will give something like none, 5, 10, 15, 20, and then let's see max features. So here it is square root, and we have only one. Earlier we used to have auto as well, but now we have only square root. So I'm keeping the square root as it is. And then let's have something called minimum samples split. This one. So I'll keep like 2 comma 4 comma 6. And again, these are all the random values, guys. Leaf. I'll keep like 1 comma 2 comma 3. Now if you look at the grade, so these are all the values over here. Now let's pass this one. So randomized search, and the model name is random forest. I'm keeping names like this, and randomized. Let's use the imported library here. So here we have to pass the model. So random forest classifier, or I can say model is equal to random forest classifier, and let's pass the model here. So estimator is equal to this one model, and then param distributions. So what the parameters? We have the grid here. Let's paste the grid, and n iter. How many times this has to iterate? Let's say like some 5 times, and CV cross fold. Let it be 5 times, and verbose. So basically, if you would like to see the output, keep the verbose as 2. 0 represents you can't see the output when it is running. 1 means you can only see the high level output. 2 means you can see all the level output. Okay, now this is the one. So what we did here, so we took the model here, whatever the for model. So whether it is a random forest or logistic regression or SPC, for everything it is the same. I mean, sorry, for logistic regression, the parameters do change, guys. I mean, these parameters do change, but the kind of concept is same. The randomized such CV estimator is equal to this one, parameter distributions this one, and n iter. So how many times it has to iterate? 5 times. And CV, how many folds I have wanted it to be, like I'm 5 folds, and this one, and this one dot fit. Let's fit the data x time y trade. Okay, let's run this one. So total 25 feeds it is happening, which is like really good. So how 25 fits? So basically, whatever the values that we have given over here, it took the sample of these values, and then so here it is multiplied n iter 5 into CB 5 by 25. So it creates a combination of this one. For example, how many combinations you can create? 1, 2, 3, 4, 5. So for example, how many combinations can create? 5 into how many are there? 1, 2, 3, 4. So the first one is a 4. 4 into 5 into 1 into 3 into 3. How much this is? like out of 180 samples, I mean, if you add like each sample one time, so this will create like 180 unique combinations. So out of 180 unique combinations, because we give like n iter is equal to 5 and cv is equal to 5, it has picked like 25 fits. Okay, now we have trained the model. Let's see the score of this one. So dot score x test comma y test. So the score is 85.2, and whereas the previous one, the previous accuracy, it is 83.61. So if you look at, for example, this is like hyper, I mean, so let's do this one. 100 round of this one comma 2, like accuracy after hyperparameter tuned. For example, let's say this one. Okay, so if you do this one, pd dot data frame, let's plot this one. Data is equal to this one, and accuracy, normal accuracy, index is equal to accuracy. Let's plot this one. Dot plot kind is equal to bar, label is equal to false. So you can see that the hyperparameter, after tuning the hyperparameter, the accuracy has been increased. So is there a way that we can increase this accuracy furthermore? Yes, we can do. So I'm going back to here instead of 5. So let's copy this one and let's paste it here. Instead of 5 here, let's keep it like 10. Okay, so now let's run this one again. So this is like running. Okay, this is completed. And now, so what I'm going to do, dot score x test y test. So now the score, it has not increased actually. So if you look at the previous one, the score, it was giving like 85, whereas now it is like 83. So now let's see what are all the best parameters. So now this one, it has scored 83, and for each and every line, if you see, there is a different accuracy, right? I mean, here we can't see, but there's a different accuracy. So out of this, which one, which record, for example, which value, which of these hyperparameters really worked out? Let's see this one. So our model name is this one, right? Dot best parameters. So our model achieved high accuracy when n estimate is equal to 150, the default is 100, when minimum sample split is 4, and maximum depth earlier it is none, now it is like 15. So something like this. So by this, actually you can improve the accuracy, and then what else, and then what you can do, like predictions, like x is equal to rf is a model name, dot predict x test, and you can predict the values here like this. So this is how you can tune the parameters. And now let's see here verbose is equal to 2, right? Let's see what is the 0. So when you run, when you keep it as a 0, you can't see any output over here. So once it runs successfully, you will see this one here. If in case if you keep here, you will see like a high level, like how many fits and all, that's it. And you can't see like how it is running, where exactly it is. And if you keep it 2, sorry, so 2 or 3, you can see everything, like the accuracy score and everything. And so you can see now this has performed like 85.4, 87.5, I guess. So if you see here, okay, yep. Okay, so this is the training data and this is the test data. So this is how you can hyper tune the parameters by using the randomized search CV. So here one thing, guys, the difference is that, so here there are like some 180 combinations out of this, and it only has to 50 folds, right, or 25 folds. But whereas in the grid search, it goes for all the 180 combinations, and then it gives the best output. So here we have given n iter is equal to 5, because how many times we have to iterate. Whereas in the grid search CV, which I'm going to cover next, so there we don't have to give this value. By default, it goes to each and every combination. So it, for the same grid, it checks for 180 times and gives the best output. So let's uh, take a look at GridSearchCV in the next video. Thank you for watching this video.